Hello, this is Matt Montgomery, sales agronomist with Burris. Today, I wanted to talk about seeding rate and hybrid type. The information we present here is a little bit different than the story you might hear in the industry right now, and I think it's pretty important. So the information that we're presenting here on this slide comes from our population studies that we do at the Burris Seed Farm. And in particular, I should make sure I reference Chip Turner, who conducts our research program and the work he has done in this area. This is his data that I'm presenting here. You know, sometimes when you hear in the industry this topic of population, you'll hear people talk about the fact that we just need higher and higher and higher populations. But is that true? I think this data that we're going to present here really shows that that's not necessarily true, that the correct population really depends upon soil, it really depends upon the hybrid type, and it really depends upon agronomics. And I want to talk about all of those and then show our population seeding rate, I should say, chart at the end of this presentation. You can see right here 2V56. Now 2V56 Power Plus 2V56 AMX would be a little bit more of what I would call a determinate ear hybrid. There's not a lot of flex to that ear. Plant it in thick, plant it in thin within reason, and you're getting pretty much the same ear. That varies a little bit, but for the most part, that's true. You can see as we look at these graphs here that we have some parabolic curves, I guess you would say, these parabolic population curves. And you can see there's a peak to each one of those curves, and then you can see there's about a 2,000 to 3,000 range on either side of that peak, where probably we're talking about the population being statistically equivalent when it comes to yield. I think one of the things that's going to jump out to you immediately as you look at this is if you look at the top graph, the medium graph, and then the bottom graph, you're going to notice that that ideal population doesn't fit in the exact same spot. It really does depend upon the environment. In a tougher environment, we really don't require and probably don't want as many plants per acre. In a higher yielding environment with this product, we want more. And that tends to be a trait, a trend that we see across the board and in all these studies we've done over time. In this case, you may notice up there in the right-hand corner that we're talking about when you go 250,000, 2,500, I should say, more plants beyond what's in that black line, that kind of statistically equivalent range, you'll notice we start to drop off on yield, and you can start to see in this case somewhere on the order of an 11 bushel drop off in yield in this particular example. Now here we have a different hybrid. It's a different ear type. We're talking about Catalyst 7893 3111. That's a structured refuge product, a little fuller season, probably one of the more full season in our lineup, 115-day RM. And you can see here that really we're talking about a different set of populations that tend to look correct for this product. And we'll show you that in comparison to that 2V56 here in a second. This is a flex ear hybrid. It's an ear that flexes, that can take advantage of thin populations, but then I would also say it can do the reverse. If you get too thick, it will actually shrink too much. And so we need this hybrid to actually be at a little thinner population, and you can see that here on this graph. You can see that, and we'll show this here in a second, the ideal spot really falls back from where we were with 2V56. It's not quite as high, and you can see it really drops off even lower when we're talking about that tough yielding environment. And there again, we see the black line, this kind of statistically equivalent range around that peak on the parabolic curve that really says if you can get within this range, you're probably going to maximize yield in this case. It's real interesting to note up here in this example again, and this is not a made-up number, this is actual data, that in this case when we went 2,500 beyond that statistically equivalent line, that upper range, again we dropped off 11 bushels. That's not going to happen every time. It happened in these two examples. It's just kind of a coincidence. But it does give you an idea that as you go above that recommended range or that ideal range, you do begin to lose yield. Now notice what this looks like in comparison to the one we just looked at. Again, here's 2V56, and you can see that determinate ear hybrid actually pushed up to where we want it to be a little bit thicker. So we want the determinate ear to be a little bit thicker, we want the flex ear to be a little thinner, and they'll both perform very well as long as we operate within those specs. Now up to this point, we've talked about just straight yield. But it's important to realize, and I don't have the data here, I'm not going to present that here, but as we go through and we look at these hybrids, we're not just looking at yield. It is not true that all hybrids require high populations. You've seen that in these two different examples. That flex ear really does not require a high population. The determinate ear does require a higher population. And it is true that ideal population varies based upon ear type and soil type. But it's not true that we just look at yield. We shouldn't just look at yield. We also look at agronomics, in particular things like standability, and we'll factor that into the equation for figuring out what the ideal seeding rate might be. And so from all of that, we develop this, a seeding rate chart for our products. And we really have a lot of confidence in these numbers. These are well evidence-based numbers. And if you're being told that you have to plan everything thick, that's not necessarily true. We really have the experience and the data to back up that that is not the case. There are some products, like those on the right, that have more of a flex ear, that we want at thinner populations, and they'll perform just as well as anything else at those thinner populations. There are some products with a determinate ear, we want to push that population up. We want a higher seeding rate. They're going to perform best if we pack in lots of ears per acre. And then we have the bulk of our products that fit in this intermediate range that aren't really determinate and maybe have varying degrees of flex, and they tend to fit very well in this B category. So you have C, the flex, A, the determinate, B, kind of the intermediate. And I would stress one more time, it is incredibly important that you follow these recommendations. There is a penalty, yield-wise, for not doing so. In last year's population studies, if you went 2,500 over these ranges, it tended to equal somewhere on the order of 8.9 bushels per acre. I can't guarantee that's the penalty every time, but it gives you the idea that there is a penalty associated with not looking at and following these recommendations. I think the final thing I might say is that there is value that you can glean from this information, that you can glean from this data. This data that we have developed can add bushels on your farm. It's an important relationship that can be leveraged, and you need to make sure that you do so. We know the specs that these hybrids must be placed within to perform best. Make sure you do that. Make sure you get as much as you can out of these hybrids by treating them right on the front end. Thanks for listening. We look forward to talking to you about more agronomic topics on Burris Agronomy U.